Thank you very much for being here, and thank you, Rob, for inviting me. How many of you have had experience with virtual reality or augmented reality? Or good. So we'll go from there. So again, my name is Pablo Figueroa. I'm coming from Universidad de los Andes in Colombia. I'll give you a little bit of context. And what we are going to talk is something that I call heterogeneous mixed reality applications, and I'll try to give more details about what I mean with that and what are the challenges that we have. So a little bit of context at the beginning. We are here, you are there. You are pretty much 10 times larger than Colombia, more or less. We have only one time zone. I think you have 6.5 right now. And yeah, it's big, and the difference is big. And we have also several provinces. We call them departments there. And most of the activity is related to this area, the central region of the country. The south region is part of the Amazon, this here and this I'm going below. This area is very hilly. There are several mountains, but not really as the Rocky Mountains that you have here in the west. They are really green. And in the capital city in Bogota is where I am. This is Universidad de los Andes. These are part of the newest buildings, and the mountains, as I said, are a little bit greener than what you have here. The city is kind of a hike. It's 2,600 meters above the sea level. So if you go for the first time, try not to run and take it slowly at least 1 week, because you will feel this high altitude problem, or some people can feel it. There is this mountain on the top that has a church on the top. Is very common in Catholic cities to have churches everywhere. But it's really nice because you can know where you are in the city looking at that mountain. The university is a private university, has about 15,000 students. Most of them undergrads, I would say 60-70%, and the rest are graduate students between masters and PhDs. And the facilities are kind of nice, given it's a private university, so they spend more money in the facilities. So I've been working for ages. I say 20 years, not to say more. But I really like the idea of doing research in VR, and research that we can use everywhere, especially in other countries as in Colombia, because I think the technology can be used in many applications that are relevant everywhere. Since in Colombia there wasn't really a lot of people doing VR, there were 2 of us doing VR for a while, and now there are more. I was doing VR and video games. At the beginning, 20 years ago, video games was like the small and really nice child of virtual reality technology. Now it's the other way around. We are the small and nice child of all the video game industry that is really huge. And we use the same technology both in hardware and in software that the video game companies are using. So in some way, it's really nice to relate both things. In Colombia also, the video game industry wasn't that big, I would say 20 years ago, and still is not that big. Let's say there are about 50 companies in the entire country, which is not that big. But they are doing well and they are growing, so it's part of what we want to show. The lab that I am inside the university is a really nice lab. We have a big visualization space. Each one of these walls is about 3 meters by 3 meters, and we have behind each one of these walls 4 projectors, so we can get an image of about 4,000 by 4,000 pixels in stereo, like the images that you get in a movie theater, a 3D movie theater, but a little bit sharper. And there are several facilities here. There are some pictures of the visualization and interaction facilities that we have. So, as I used to say, we have a lot of toys. It's really nice to have them, but it's also nice to have people working with those toys. In terms of applications and things that I've been doing, there are several applications. Companies would like to use VR for many things, and the most common things right now are related to 360 videos or 360 stills. And there are these companies doing furniture, selling furniture in the country who would like to see how that furniture will look in your apartment. So we are trying to get a close enough idea of how is your apartment and put the furniture there. And that is a company that is working with us for that particular application. Interactive spaces, this is just two screens with a Kinect. It doesn't show that well. And I think this was a video, but probably it's not working, of course. But the Kinect allows us to interact with the people that is around. And you may say that the Kinect is a kind of an old technology right now, and it is in some way. But it's still something that is very interesting if you want to have people interacting without using anything in particular, just moving their hands and trying to do some gestures. So that is something that we are using just to get people involved in these interactive environments that doesn't require any particular tool. This is an image of a program that we have in Coursera. Coursera is one of these huge companies that are doing massive open online courses. We have 5 courses in Spanish. Sorry for the ones that don't speak Spanish. But well, Coursera created these sites in different languages. I think first was Chinese, second was Portuguese, and third or something like that was Spanish. And we have 5 courses in game development in Unity. That is something that I'm doing also. So without further introduction, let's go to the topic that I want to talk with you today, which is this idea of having collaborative environments that could be virtual reality or augmented reality or both, which is why I use mixed reality instead of just using VR or AR. And this picture that you saw at the beginning and also here is an idea of what we want to do. Let's say you have a lot of toys, VR and AR toys. You want to create environments that are shared between these toys, and you want these people in these environments to collaborate between them or play if it's something that you would like to do. In this case, we are playing. I'm using a Hololens, an AR equipment. There is one of my students using an Oculus, which is, I would say, high-end consumer VR right now. There is another student using a Gear VR, which is just a cell phone in front of you, which is lower cost. It's a little bit less powerful, but nevertheless is very interesting for showing demos. And we have one of the students just using a PC, and the 4 of us are just playing a very simple game that I'll show later on. So we are trying to use this technology from several equipment in the mixed reality continuum, and we want all of them to collaborate, or in this case, to compete. So we have multiple clients, part of the distributed environment, multiple locations in this case. We are just in one place, but with Rob we'll start working on what happens if we want to have shared environments in Canada and in Colombia at the same time. So there are other issues that we want to solve at that moment. Several hardware setups, as you can see, each person has pretty much a particular hardware setup in VR or AR. And we want them to collaborate in some way. And in the case of games or these environments, we want to have some equivalent performance, or we could say equivalent metrics in which we can compare these different environments. So that is what I call the heterogeneous distributed mixed reality. Heterogeneous because each one of us is using different equipment, and that will happen more frequently because there are so many companies doing VR and AR tools that we would like to use. Distributed because we can be in just one place or in several places. And mixed reality because we don't want to have only VR, we want to have AR and whatever is in between and collaborate between us. So there are several challenges in the creation of this type of applications. The first one, I would say, is the common set of tasks. We want to, in some way, implement the same tasks in different environments, and that, per se, is a lot of work trying to repeat whatever you want to do in all these environments. The first thing that you can do is you can use tools like Unity or Unreal, and these tools are very powerful because they allow you to migrate your code to whatever you are using. So in Unity you can create your code and you can then decide that you want to deploy in an Oculus, or you want to deploy in a Gear VR, or you want to deploy just in your PC, and it's pretty much like buttons and saying play. However, the problem comes when you start deciding that each one of these environments have different ways to interact. For example, the Gear VR has something like a trackpad here on the side, and the Oculus have these very nice controls or something like a clicker, and the Hololens has some gestures that you have to do in front of you. So the interaction in each one of the environments is different. So it's not as easy as saying, I want to deploy this into the HoloLens, or I want to deploy this into the desktop and just play. You have to, in some way, change the code and change the interaction techniques to each environment. So that's what I refer when I say we would like to have the best interface possible in each hardware setup. And we'll try to define what is the best, because there are different ways to understand that adjective in each environment. We want to have similar metrics. I was saying, for example, if we have a game, we want to be fair with all the players and to have the same opportunities between all players. And probably you have had several experiences when you play online any of the games that you probably play more than what I play. And one good example that you can see some papers in the network right now is Fortnite. Fortnite has several implementations, and until very recently it was very difficult to have these implementations to play together, because it was a little bit unfair to play, let's say, in a PC and in a mobile at the same time. The mobile has some limitations. But people at the Fortnite development team, they are trying to get the best interface in all these environments, which means the Fortnite implementation in a mobile is a little bit easier, or it has less graphics than what you have in the PC. So the performance and the response time that each user has in some ways comparable in each one of these environments. So we'll talk about these metrics a little bit more, but we want these environments to be comparable. And the last issue, when we do research, we want to show that we are great and we have some results and our interface is better than the other guy who did it before, or in some way we are doing something, we are contributing to the state of the art. So we have to do, usually in our field, we have to do user studies. We have to show that this actually works for somebody. And in our case, and I'll try to show some examples, it's kind of tricky to develop this type of user studies, and I'll try to show you why. I'll skip the related concepts because this is a little bit of related work from the past, but I'll try to come back. But I want to go and show you some of the examples that we have created, and just to mention some of the problems. Most of the examples that I will show are things that my students, master or PhD students, developed in the last years. And unfortunately, most of them have issues that preclude us to get this great publication that we would like to have right now. But I hope that you get the idea of what are the problems, and probably you will do better, and there you are, you have the publication that I haven't had so far. So the first idea is, let's say we want to buy a ticket for an opera theater. Currently, you probably go to these websites and you just pick the seat, or you press this nice button that says select me the best seat available, and that's it. That is what I want. However, sometimes we want to be more picky, and we want to check exactly how this opera theater is, and we would like to experience how does it feel to be in a particular seat in a particular opera theater. So with some collaborators in France, we got a model of an opera, a theater that they have for opera there, and we are able to see and to listen how this opera will be experienced from different points in the theater. And ideally, it will be really nice, this environment, so you can decide which one is best for you, because depending on the size of the theater or depending on the acoustics, things will be very different. So we decided to create this environment for an opera theater. The task is very, let's say, simple, is to listen how this singer or how we feel the singer from different seats in this theater. And we decided to make two implementations that are totally different. A cave that they have this is a collaborator in France, they have a 3-wall cave, really nice, 2 by 3 meters each one of the walls, and really well calibrated, not as ours because we have less hardware than what they have there. And a Gear VR, which is the cheapest head-mounted display that you can get right now. And we try to implement the same task in both environments, which is in some way easy to do. We created this environment in Unity, and we can port that environment to the cave and port that environment to the Gear VR. And we change the interaction technique. So in the Gear VR, we can select what is the chair that we want to go by looking at it and just clicking, and we go there, we teletransport there. And in the case of the cave, we have this wand that the person can use to go to a particular place. So in some way, the two environments were interesting and easy to do. Here we can see the visualization for the cave. Something that we try to experience also is that in the cave we can have a more realistic environment. We have more shadows. We can have people that are more realistic. We were putting people sitting in the environment just to show what were the seats that were already busy. And in the Gear VR, since we don't have as much hardware, we change these, let's say, high-resolution avatars for just dummies, just cylinders that show that these seats were occupied. And we tried to create an environment in which we allow our users, our subjects, to select which one was the seat that they preferred. And in terms of the study, it's called within subjects study because the same person was using both the cave and the Gear VR to see which one they prefer. It's also called counterbalance because some students or some subjects were using first the cave and the others were using first the Gear VR, and then everything that probably you know on how to do a good experiment. The end result, unfortunately, subjects prefer different seats if they are using the cave or if they are using the Gear VR, which means that depending on the gear that you are using, the tool or the head-mounted display or the cave, your preferences change, which is not very good for VR because we want the media, or in this case, the cave or the gear, to be invisible and just we would like to concentrate in the experience of selecting a seat. But unfortunately, that doesn't happen yet. Why? There are several reasons. For example, the field of view in the Gear VR is smaller than what you can get in the cave. And that means that when you are in the Gear VR, you feel like the space is smaller, despite the fact that we try to do our best to get the best calibration possible. You nevertheless feel that it's smaller and you feel that you are better sitting far away because you can see more of the space. Whereas if you are in the cave, you have a wider field of view. The space feels a little bit better and closer to what is the real space in the real opera theater, and you select a seat that is closer to the singer because you want to feel this personal experience of being closer to a singer. So we tried, and that is something that we are doing in this idea of HDMR applications. What you can do, what changes you can do to the experience in each one of the environments to make the experiences closer. So what we were doing, we were scaling the space. It was virtual, so we can do whatever we want. We were scaling the space in the gear in order to make it appear larger than what it's in reality, and in some way to compensate to the problem of the smaller field of view. But still we are having problems allowing people or getting people into the idea that they can select the same seats in both environments. Another thing that you have to realize for this type of studies, if we are doing within subjects, people have to try both environments while they are in the experiment, and that means that the experiment at least is twice as long as trying just one environment. And usually our experiments run for about an hour, which is okay if you have students and you have the power to force them to be there. But if you have, I don't know, just volunteers that go to your room to try, it's more difficult to convince them to be there just for an hour, just because technology is nice and you are such a nice person that you want to do an experiment. So, first experiment, 2 different environments, 2 different experiences, unfortunately. Yeah. Second experiment, a competitive game. This is a very simple game. Since we had this failure with the first one, let's try something simpler. And this one is very simple. I think it's called hot potato here. So you have a ball and you throw the ball until somebody says stop, and that is the loser, the one that has the ball, and you do something with that person at that moment. So here was very simple. It was with a timer. You have 4 people. All of us were portrayed with this robot or very simple avatar, and the only thing that we could do in the environment was to pick which one of the other 3 people, well, 2 people, because somebody was throwing me the ball. We couldn't throw it back to that person, so we had to choose from the other 2 people which one we want to throw the ball and throw it to them. So that was the only thing that we were doing. We had more environments. In this case, we were using, as you saw in the picture, the Oculus Rift, the Gear VR, a Hololens, and a desktop PC. And we were measuring how much time we spent on passing the ball. So we could identify when we were receiving the ball, and we were also able to identify when we were passing the ball, so we could measure that time for all the environments. And we also did that within subjects study. But in this case, again, within subjects, we were trying all the environments. It's not entirely within subjects because each person will have to try 4 interfaces. We were trying just 2 interfaces and do something in between. Each person were trying just 2 environments. In this case, what we could do is, at the beginning, we identified that the HoloLens was always the loser. And the main reason for that is that we were using the best interface that Microsoft wants us to use for the HoloLens, which is gesture-based. There are 3 gestures. You can do this, you can do this, and there was another one that I forgot. Dragging, I think you can do dragging. Yeah, which is really nice, but that takes time. The time for identifying this gesture is about 10 times slower than just clicking a button or tapping your Gear VR or doing whatever the other environments could do. So that is what I was referring when we have to define carefully what means the best interface for each environment. It has to be something that is natural for that environment, but also that is comparable to the other environments that we are using. In this case, for the HoloLens, it's really unfair to use this gesture. It's easier and better for the HoloLens user to use a clicker. And the HoloLens comes with this nice clicker that you just press a button and you are as fast as the other environments if you want. So we could implement in all the environments the same interface with the fairness in time, so all of them could be faster if we change the gesture for the clicker for the HoloLens, and then we could play and nobody is the usual loser as at the beginning when the HoloLens was. What is the problem in this environment? It's a little bit long to make the experiment if we really want to try all the environments for each one of the subjects. And if we try only two, the person in general gets the idea, but since the task is so simple that it's just doing one thing, they don't see the point why I'm trying all these environments. Yeah, because it's a very simple task. I can do it only with the Gear VR. The other thing is we wanted to reproduce the same environment in reality. I mean, we wanted to sit the same people in the same positions as they were portrayed in the virtual environment, just for the sake of using the HoloLens in a proper way. Because, well, we could see the users. I want to pass the ball to this guy or to that guy. That calibration, although it could be feasible it's easy to do it, we didn't do it for the study, and they were a little bit lost on why we were using augmented reality without taking advantage of the environment, the real objects that we had around. So I would say this is the best that we have done so far, but still there are some issues in terms of how you portray the task and then how you take advantage of each one of the environments.
Can I ask a question?
Sure.
So you are looking at log files, I assume, that to measure the time. Are you manually, like by observing the players to measure the time, or are you actually identifying the event, catch the ball, and measuring for the log?
From the application. It will be, this is a very good question because it depends really on what is the metric that you use, but the more automatic that it could be, the better. In this case, it's very subjective. In the case of the opera theater, what is the best is what the user wants. So he says this one or that one, and we could pick that from the event, but nevertheless it was subjective. In the case of the game, this was just the events. We knew from the application at what time I was receiving the ball. We record that time, and when he was just throwing the ball, either with the tap or whatever they were using, we record that time and we had the difference. And it's the best way to do it because first, you want to do this several times, at least I would say the gold number that we use is at least 20 subjects per environment that we want to try. So you have a lot of data if you really want to record that information. And if you do it by hand, for sure there are many errors that you can commit in the middle. So it's better to do it by the application. In this case, there were several repetitions also, so they were playing for, let's say, 2 minutes. So I think we record at the end like 1,000 ball passes. So it's just a lot of information to do it by hand.
So how does it work? If I want to send to other person, do I click the other person and say send the ball to other person? Is there any synchronization between me receiving the ball and the other person sending it to me, or do I receive it right away?
That is a good question. The environment is actually 4 applications isolated but running in the same network. they have to share in some way a networking technology. In this case, we were using a library that is called Photon. They use it for games, and you can get a free version for with certain limitations, but we can also buy it for more users if you want to use it for more. But for four no more, it's easy to just to use the free version. So there are 4 applications running. Let's say the Gear VR. In the Gear VR, what you can get is the 2 events of somebody pass me the ball, and now I have the ball and I start counting. And when I press this button and I can pass the ball to that guy because it's not myself and it's not the same person who sent me the ball, I can record that time and I have a measurement. At the same time, the person who sent me the ball, he's running another computer and he can record also both times. So we were recording information. All those 1,000 passes, probably you can get 300 or 400 in each one of these applications. And there are some measurements that are a little bit different depending on the latency. But in the same room, the latency is less than 20 milliseconds. It's not that much. So there are some differences, but you can record the same set of events in both computers, and you can later on compare them if you want. But they are pretty similar, so it's not an issue if you are in the same room.
So each player running their own standalone and on their computer, and metrics are collected within individual computers, not on one server.
Yeah, in each one of the computers. It's also important because if you try, let's say, to have one computer collecting all the information, you might do it, but when you go to the network issues, there are these 2 protocols that you can use. The standard one that most of these computers use is TCP. That in some way what it does is it sends an event to the other computer, but it waits for the acknowledge that message was received. So in TCP it's okay because you will be sure that the information got there, but it takes twice because you are always waiting for the acknowledgement of the message got into the other side. And that is what usually all the input devices use, except trackers. Trackers, since they generate so much information, it will be very costly to wait for each one of the messages to get an acknowledge. So what they usually use is what is called UDP. And UDP is just, I'll send the information, and I trust that the network is good enough that the other guy will receive the information. So I don't wait for the acknowledge. And that means that I'm at least twice as fast. But if some information gets lost, I'm assuming that since I'm generating so much information, it doesn't matter if there are 2 or 3 messages that got dropped because networking issues. So in this particular case, yes, you can have another computer that is saving all the events. It's good if you do it in a UDP fashion, so you send the information and you don't wait for acknowledge because it will be twice as slow. But you can also, with current computers, save it in the memory of each one of the computers that you have, and at the end of the experiment, save the information to, let's say, a file or whatever database that you are using to save the information. Because again, let's say you are in a PC, you have a hard disk and you are starting to save information in the hard disk, that takes forever to go and save the information there. So you save it in memory. You have, well, most of the computers now have 8 gigs, 10, 16 gigs of memory. It's not really an issue. You save that information in memory, and once you finish your experiment, you save it and you have the information there.
Maybe after the session.
Sure,
Yeah.
sure, please. And if anybody has or questions, please interrupt me because I'm about to finish and I don't know what else to say, so. Please be my guest.
Can I ask a question there?
Sure, sure.
So you were mentioning with the Opera specifically the Opera, but also in the hot potato game, that these were all performance-based measure. Well, at least hot potato was. In Opera, you noticed that there was differences in seat selections according to which device they used. You mentioned that that was a failure of the experiment. But I was wondering, could we look at that another way, that these different devices have different affordances, and that perhaps you can build some sort of framework on top of that that says, okay, when you're using a cave, this is what you expect. So I'm imagining an opera house that has different seating for different types of device users or something.
Mm-hmm. It's really a good point. And that is what is the current way to do research in this type of environments. Each one of our VR setups or equipment that we have different affordances. They are in some way designed with different capabilities, and those capabilities in some way imply different affordances. The problem is that we don't know yet what are those affordances that are coming. We know that it's in some way better to have bigger field of view. We know that it's better to have higher frame rates. We know that it's better to have hands and not just clicking. But what happens if you just have clicking? Yeah, it doesn't. It means that you cannot do all those tasks that the guy with hands can do. And from the other hand, well, in that sense, what I mean is this idea allows us to really understand what are the differences between the environments. And that is something that we really want to nail down. We still don't know exactly, since these capabilities are so different, what that means for particular tasks that we want to implement. The other thing is, I have a friend in Iowa that has a 6-wall cave. I cannot afford it. There is no way. No. But I want to do caves. I want to do things in caves. And that guy can brag about his 6-wall cave and all the things that he can do. But I can try to adapt my 3-wall cave and get the best of it. And probably and hopefully I can do a little bit of what he's doing in the other cave. What I mean is we have to overcome in some way these differences and try to make as close as possible these environments. If we ever want to create an environment that we can share among us. If not, well, we can buy the world by the Oculus version that everybody has Oculus, or the Vive version that everybody has Vives. And if we are everybody in Vives, it doesn't matter. If we are everybody in Oculus, it doesn't matter. But if we have different equipment, we cannot collaborate. So there is something related, and I skipped because I wanted to talk a little bit more of the issues here. There is a lot of work done on asymmetric tasks, that you have, let's say, a cave and a Gear VR, and both are doing different things because each one has different capabilities. But what happens if you want to have the same capabilities in the Gear and the cave? That is, I would say, is a tough question because we know they are different, but at the same time, we don't exactly know why. Yeah? Okay. More questions? No, not yet. Good. So this is the competitive game. The metric, the specific metric here was time to pass, and that is what we wanted to do. Sure.
Was there any, like, it seems like the I guess the slowest path in the competitive game was just the input mechanism. Was there any, or is there any idea that, like, the visual, the output from the game seen as impacting time?
That's a very interesting question because the field of view of the HoloLens is the smallest. And we were thinking that maybe that could be difficult because you have to move more your head in order to see who sent you the ball and to whom you can send the ball. And we discovered that it's not an issue, and we don't know exactly why. I think part of the issue is that we try to make this circle among the 4 people small enough so you can see who is throwing the ball. So we make the field of view not an issue. But I guess if we get more people involved and you have to really move your head more, it will become an issue.
There was animation when you threw it, right? Like
Oh, yeah.
the ball. Okay.
Yeah, and the animation is kind of simple because it's your entire torso. You are doing this. In the case of the Gear VR, in the case of the Oculus, we were trying to implement torso movements because you have your hands. We were trying to make it, but it wasn't really a point for this game. So I'll show you another
I was
one.
just saying because if you saw the ball coming at you, you turn your head and you'd have a little bit of air as well, right?
In general, you never notice that the ball was coming at you because it was so fast in terms of the implementation that we did that it wasn't really a matter of catching it. It was just noticing what was the feedback when you had the ball. You had some feedback and sounds that mentioned that you had the ball at that moment, and the counter, you start to see the counter that was going down, so you had to throw the ball. But that question about the time is very interesting because in this case the field of view wasn't the issue. The issue was the clicking to throw the ball.
Be interesting to see if you could get the same interaction technique for all the displays. Let's say all the input techniques with the different displays and see if it still had a big difference there.
No, it's what I meant. We made it. In the case of the HoloLens, we used the clicker and we got the same time in all the environments. And it's not exactly the same input because in the case of the HoloLens and the Gear VR, it's like clicking. But in the case of the desktop, it's the space bar, and the case of the Oculus Rift is a different, the clicker also in that case.
One of our remote participants is asking, as someone who has also used the HoloLens, are you looking forward to the second iteration?
For the game or for the HoloLens?
For the HoloLens.
I'm expecting my Magic Leap, not the HoloLens 2, which is also an augmented reality equipment. As far as I know, in terms of field of view, it's pretty similar. The technology, it seems that it's a little bit better in terms of the contrast that you get from the image. What we didn't like about the HoloLens, which is really nice at the beginning, is that the entire computer is in your head. Yeah, everything is here, so it's very nice because you don't need tethers, you don't need cables, you don't need anything. The problem is all the weight is in your head. So after 5 minutes, you really notice the weight. It's not that much. I don't remember, it's 6 pounds or no, it's less. It's 2 pounds, I think. Yeah, I think it's 2 pounds. It's not that much. But after 5 minutes, you really notice. So I don't know how the new HoloLens will be. I'm pretty sure they will try to keep the same form factor that everything is in your head. And probably because technology goes so fast, it will be way lighter. But we could notice that despite the fact 2 pounds doesn't sound that much, is reasonable. Well, it's terrible after 5 minutes.
Wow, I did not know that.
Sorry?
It makes sense, but I didn't know that. I didn't realize that. It seems like such a great piece of technology, but
Yeah.
the discomfort of wearing that even after 5 minutes, I can imagine.
Yeah, yeah, and you don't notice it at the beginning because it's just the wow factor, but after a while, please take this out.
But it occurs to me that you could repeat some of these experiments with parsing apart some of these factors. So wear the Oculus Rift with extra weight added to it to match the HoloLens, for example, and see if that matters, or artificially constrain the field of view in the Oculus Rift
Yeah.
to match that. So you can parse apart a lot of these factors and figure out which ones really matter most in this kind of.
That's a very good approach also, and it has been used before. There is this idea that you can simulate a head-mounted display with a cave. So if you have a big cave with, let's say, 180 degrees field of view, you can create a smaller field of view by limiting what you are looking at the cave. And in some way, you can simulate the real environment. The problem is that each one of these environments is so different that getting the actual simulation, I think, is too costly. For example, the frame rate for the Oculus is 90 frames per second. How that compares to the 60 frames per second that you can get in the Gear. You can simulate it, yeah, sure. You can reduce the frame rate in the Oculus, but I don't know how if it's really comparable to have an Oculus Rift with 60 frames per second with a Gear VR with 60 frames per second, because the quality of the image is different. And what they were doing in the past with the Cave, yeah, you can simulate a 60 frames per second, I don't know, a 50 degrees field of view head-mounted display, but again, the visuals and the tracking that you are using are way different to what you have in the other environment. Tracking is the other issue. In the Gear VR, you have this magnetic and, well, built-in tracking from your cell phone. In the Oculus Rift is this camera that goes 60 frames per second. And again, you can try to see if you can make them comparable, but the technology is so different that we didn't see a point of simulating. It's in some way better to try the real environment and see how we can compare them. They are too different. Maybe is what I would say in your regard. They are in some way different, and knowing exactly what is the reason for the differences sometimes could be tricky. But so far we have found what are the main reasons. In the first case, as I said, is the field of view. In this case is the clicking, the input device that you use. But again, it could be more complex. The third environment that we did so far is a collaborative game. And we thought this was the end of our experiments. This is the one that is going to be great and perfect. In this particular game is something like an escape room, 2 escape rooms at the beginning. There are 2 people. Each one has a little tutorial at the beginning. They are trying their tutorial, and once they try the tutorial, they finish their first room and they get to the shared room in which they have to collaborate in order to finish that particular room, and then they have a third one that they also have to solve. So 3 rooms. The first one is different for each one of the users, and they collaborate in the last 2. We used 2 equipment, in this case the Vive and the Gear. We wanted to have different implementations. So the SDK for the Vive is different to the SDK of the Gear VR, and that's why we use those 2. And we use several metrics. We had here time. What else we had, Johan?
Quantity of tabs like do for any specific task.
The number of tabs that you were using, how much input you had in each one of the environments, and how much you walk,
The distance of each one.
and how much space you were traversing in each one of these rooms. But I would say here the most important for us was what was the perception that each one of the users had from the other. Because we did a really complex setup for our study. Each one of the subjects were in different environments, in different physical spaces. They didn't see the other person. And we wanted to check if we could trick this experience so the other person didn't notice that the other subject was in a different head-mounted display. So we wanted to see if we could in some way abstract the interaction and hide the differences between these 2 virtual reality setups.
They talk
They could, yeah.
throughout the voice over.
It was voice over IP on top of the application that we did. Yeah. So, really nice. We did 2 implementations. In the first one, we started to run our experiments and we failed miserably. When 2 friends came and the friend from the Vive said hello to the other friend, and the other friend was like this all the time. So he started to say many words. What are you doing? Why you are not waving to me? And of course the Gear VR, we didn't, since the task wasn't related to waving, we didn't implement that. So first lesson, your body, coming back to the affordances, your body in some way has some affordances that you expect to use. If you see another guy that has 2 hands and 2 feet, you expect to do this or to walk. Yeah, it's the natural thing. And you weren't able to do it in the gear VR. You could only do it in the Vive. And that was the first experiment, the first failure. And the lesson for us is it's really important to take into account what you expect from the avatars and the affordances that you show in the virtual environment. Because if they are different, of course, you will notice the differences. The other thing is, if the 2 environments are different, there are several things that you have to hide. For example, the Vive can walk a little bit in its space. In the case of the Gear VR, you cannot really walk, but you can try to make it in some way similar by animating what the Gear VR guy is doing. So if he wants to teletransport, instead of showing the walking or the teletransporting, you can have the same in both environments. And we decided to make both environments like teletransporting to the place that they were aiming. And the third thing is the Vive can just point to wherever he wanted to point. The other guy can only say, I want to touch that or this, and click. So we had to create some animations that were in some way believable in order to allow these 2 people to appear like if they were in the same space.
I want to add something with, for example, the movements of the Vive version. We try to reply in the gear version, but the person who is using the helmet, the gear helmet, couldn't see all the movements because it could be a little confusing these kind of movements when you are walking, for example, and keep doing what I'm doing that. So the movements were only available for the other person. I don't know if I'm clear.
So the feedback was for the other person and not for myself. So let's say if in the Gear VR I want to walk, what I will do is I will transport to that place, taking a certain amount of time. But I won't move the head of the Gear VR like this, as if he were walking, because that will create a lot of sickness for the Gear VR guy. So there were some effects that were available for the other guy, for the sake of credibility for the other guy, but not for myself. So we did the study. I think the last one was very good. We are still trying to get the publication, but the reviews that we have had so far is this has been done before, distributed applications has been done before, and this is nothing new. Okay, we have to make our case better. But in this one, the other thing that is interesting here is, as you can imagine, the Vive guy has a lot of input buttons and input gestures that is richer than what the Gear VR can do, because he only has this trackpad. So the Gear VR guy had to do a little bit of training in order to understand how these 6 or 7 things could be mapped to the trackpad that he had here. And that took some time. And in the environment that we did, it was the 3 environments that we had, the tutorial, the first shared environment, and the last shared environment were together in the same experiment, and that made that the Vive subject was waiting until the Gear subject was training in the first environment. The training in the Gear took longer. So despite the fact that the experiment was a little bit fair, and the third environment showed us that both users could do the task in the same time, the Vive user took notice of the longer time that the gear user require for training. So that for us means that we have to separate training and the real experiment. And that means that we have to make our subjects to go to our lab twice, once for training and the other for doing the experiment, which is something that none of our students want to do right now, but that is another issue. So what we have learned so far, it's possible to hide the differences, but it's difficult. But we have managed to make the environment the same for all the people who are inside this shared experience. This is what I just mentioned. Training should be separated from the actual experiment because training for some environments will take longer than for the others. Perception issues remain. What I mentioned about the waving is the easiest example, but there are subtle examples that are difficult to hide. And it's just because if you see a body, you expect the other body to work in the same way as in reality, and that is still not the case. And between subjects are very complex to perform. Here, Johan is one of my students. He unfortunately fortunately has a very supportive girlfriend who was helping him to do all the experiments in two separate spaces, which is something that I'm pretty sure we cannot do very, very frequently. What is the future work or what we can expect to do in the future? There is another experiment that we are doing. Let's say, for the sake of doing it fast, we are trying to walk in this triangle, and we are using different environments. One a treadmill, and the other is just a joystick or just pointing to wherever we want to do. And still, there are two environments here, one based on the Vive and the other with the Gear VR. Still, there are differences between environments. But what is promising for us, these are the data for the people in the Vive. And this is the real or the final goal that we have. So we are very close to have people that walk almost as in reality. And this is the data for the Gear VR. We can notice that people are in some way farther to what we expect them to have. But we want to see how we can make this smaller and closer to the people in the Vive. And we are starting to compare how this may work. We need better statistics to compare these things, and I'll show another thing about it. The adjusting of this perception to make it closer to this is still something that we are still working on. And once we manage to make it work, you would like to have some kind of button or nice tool in your Unity or Unreal environment that allows you to just fix this and make everybody happy and work in the same level of performance. What I was saying about the statistics, if the data that you have is not uniform, you will never be able to compare different distributions. So in this case, this comes from this guy in the last century, Ascom, that noticed that different data could have the same average, the same variance, the same standard deviation, despite the fact that the data are very different. And I encourage you to look for the Datasaurus dozen, and you will notice this picture and the Datasaurus that is very interesting. So without any further slides, I thank you for your time, and I'm open for more questions if you have.
Any questions?
Yeah, I wonder if you've looked at anything that incorporates streaming media. So, for example, the killer app might be, you know, the Leafs go to the playoffs. I'm from Toronto, so if hell freezes over and Toronto gets into the playoffs, you could probably get 2 million people to attend that game, but unfortunately there are only 20,000 seats. So the thought is, well, what if I could put a camera all around the rink and stream that back in some sort of broadband pipe into a headgear, right? Not unlike the opera singer, it's the same app except it's sort of more real time. Have you looked at incorporating that streaming media component into the headsets?
Not yet. The closest would be related to what I showed about the apartment where you have this furniture, this new sofa. And that comes into the field of computer graphics, how you represent reality in a way that you can ship it to another place and see it from wherever you want to see it. So there is this really nice research on something that is called light fields. And there are really nice cameras. They were showing one last year in SIGGRAPH that allows you to capture not only a picture from this point of view, but several pictures, let's say. And once you pack that and you stream that in a certain way, that in the other side you can move and you can notice the parallax between places. The guys at the sports as NFL are really good because, as far as I know, they have standard positions for their cameras, and they can do very nice tricks, as you can see, like how many I don't know, yards are for the goal, and you can see that in the real environment with the proper occlusion. So if the person is on top, you can see that is occluding the signal. So that might happen. Is not really a matter of this technology. It's a matter of packing the information in a certain way that is possible to transmit it to the other side in a fast way. And light fields is something that I encourage you to check. That is what they are doing in that sense.
First of all, thank you for coming here to give us a presentation. I found it very interesting.
Thank you.
I want to ask you, what is your students' preference as most popular? Like, do they choose graphics on top of fun, or like which setup do they choose in your lab most often?
My lab is very fortunate that we can choose all of them. And part of that is because it's very cheap right now. When we did our cave, it was back in 2006. And we would love to have at that time they were already 6-wall caves. But the price for building one of those 6-wall caves plus the people who is required to keep it running all the time was just too much for us. So that's why we created a 3-wall cave, and it worked for a while until our students left and some things started to break. Right now, it's very easy just to buy 10 of these and 5 of these, and well, no, I don't buy 10. Let's say 1 of these and 1 of these and 1 of that, and you can just try all of them. And right now, we are very fortunate to have almost everything we want. This year, there are at least 3 new helmets, both AR and VR, coming, and it's not that difficult to buy them because all of them are less than $3,000 in that price range, and before each one could be $30,000, and that's it. We couldn't really buy it. So we are fortunate to have all the toys. The unfortunate part is, for example, we have one of the Lenovo head-mounted displays that are inside-out tracking, so they have 2 cameras, and you don't need tracking outside. The cameras allow you to know where you are looking at. We don't have students to try it yet because there are 6 other head-mounted displays in the lab. The other 6 students are playing with those. We need a new student to try the Lenovo. And there are 2 new coming this year, and I don't know, I don't have the 2 new students to try. So I think it will be a matter of time to have the perfect head-mounted display, and the form factor is still evolving. For example, we would love to have eye tracking in these head-mounted displays, because it's very important to have the right graphics at the right place, and also to have some idea of where you are looking at. If you want to reproduce an avatar in the virtual world, it's really nice to see that I'm looking at you and not looking at him. And that is not possible to do in the current technology, but it's coming. It's really coming very soon.
In terms mentioned that you would like to get better statistics. Is there any platform you prefer over in terms of providing better metrics and more accurate timing for the events?
I think the accuracy is not an issue in terms of the measurement. It's an issue in terms of how good you can be creating an interface that is fast enough. For example, there is, again, an example from games. There is a description of the interface of the mobile implementation of Fortnite. So they try to do several changes in the interface to get the performance as fast as the person in the PC could be. Sorry. And they identify what are the tasks that cannot be done so far as fast as in the PC. So the measurement, if you do it by the computer, is not an issue. The problem is how you come up with the right interface that allows you to be as fast in a mobile, let's say in this case, as you are in the PC. And that is not easy because it's really a matter of trying different ways that we have tried in the past. There are so many interaction techniques for, you'll see in Rob's class, for navigation, for selection. There are so many ways to do it that you really have to try what is best for a particular task and a particular game, in this case, that you have. And once you have that, you can try to compare and see if you're fair or not. But still the problem is that it's in some way a handcraft to try to find what are the best interaction techniques for a particular implementation. The other thing that is difficult is that in standard user studies, what you do is you try to measure the differences between your implementation with a basic implementation or with something that you will compare to. But at the end of the day, you're measuring differences. In this particular field, you want to measure similarities. You want to see that both populations are the same, that they behave in the same way. And you will come up in the best scenario, you will come up to graphs like what I have here, in which these two populations will be together in the same place. And we can try to see, in this case, the distribution is not as bad. The distribution is pretty much uniform. So it's not a problem. But if we have other types of distributions, we don't know exactly what to do. Because here we can see that populations are different, but the statistics that you get are the same in all the cases. And you cannot tell that, you cannot say really that all those populations are the same. They are really different. You can see the data. So what I mean about better statistics is that we still don't know how to compare things that are similar. We know how to show differences, but similarities are a little bit more difficult.
Are we going to get the slide package?
Yeah, sure. I'll talk with Rob and we'll get it, of course.